Hey folks, how's it going? Welcome to We Need Our Space Live. It's as if I just popped in here, isn't it? Well, okay. It is the last week of spring. Summer starts on the 20th, so I figured we can wrap up spring here today. Look at some of the constellations we can find in our sky, some planets, some stars. Take a visit to some of those stars up close to see how different they are from one another. Take a look at those planets as well and find out why we still use constellations. So I'm kind of wrapping up spring today, and then summer starts on the 20th. And then the following week, a new Summer Sky Tonight show. Okay, so alrighty, let us begin. Make sure I've got everything just so. All right, so let me check the comments real quick here. Okay, so everything is running fine. Great. All right, let us begin. And as we always begin, I like to start off here on planet Earth at Lake Pontchartrain. Now this looks very dark right now because it is in real time, 7 o'clock. The sun has begun to go down. So let's lift off of our planet. And as we leave, the data is pulled in from the internet. We will begin to see our atmosphere. The clouds will then come into view. We will see how it is getting dark in our neck of the woods. Of course, not all the data is being pulled in. That's why you have this strange anomaly over there. That's quite okay because we're not going to be using this too much. But I did want to show you this. Here we go. So we see these lines here. What do these lines represent? If you've seen the show before, you know that these lines represent the orbital paths of the planets. This orange line there represents the rotation of the Earth. Let me see if my cursor is viewable. Yes, it is. Bueno. So these are the orbit lines of the planets. And when I back up a little bit here, we can see the moon over there. And as I back up more, we will begin to see the other planets closer to the sun: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And that little green line right there, that is little tiny Pluto. Well, we're not going to go out into space just yet. We're going to go back home to Earth to view some stuff from our own backyard. Now, the reason why I brought these lines up here is because I want to show you how the constellations that reside along this path, the path that all of these planets take, those constellations are called our zodiac constellations. And you can see how these constellations are colored red. Scorpius, Sagittarius. We've got Virgo, and we've got Leo right there. I'm going to pause at Leo. You can see how the other constellations above are colored differently. That's why we are differentiating between the zodiac constellations and the other constellations, the 88 officially recognized constellations. Well, we can find this constellation very easily in our backyard, in our nighttime sky. This is known as Leo. Let me turn on the labels here so we can see what they're all called. There we go. Well, that is Leo. Very easy to find, and we will go over Virgo as well. You better see me. Let me just minimize myself here. Don't need me that much. All right, forgot about that. Okay. So we have Leo here. Now, whenever you see Leo, you might not see a lion. His head, the mane, and his body, you might see a mouse. A little mouse here eating a piece of cheese with his little tail there. So either you see a mouse or you see a lion. Well, whichever one you see, this backwards question mark, this fish hook shape is easy to find in our nighttime sky. In fact, here's a picture from my backyard. Actually, it is across the street from my backyard in the baseball field. Now, I have taken the liberty to sort of highlight the stars that make up Leo. This is a long exposure photograph here, but try to find Leo. Try to find that backwards question mark that lion shape. If you have found that, congratulations, you have found Leo. So Leo is very easy to find with that backwards question mark, but we can also use something called star hopping, where we can use stars and constellations that are easy to find, and we can use those stars and constellations to find other constellations. And we use these constellations to locate deep sky objects and to sort of find our way around the sky. It's kind of like a map of the United States. We know where all the states are at. We can easily communicate with each other, where we're going or where we have been. So to do that, I'm going to bring up another program here. Oops, wrong program. There we go. And this is how we're going to do some star hopping. Now, I'm sure many of you are aware of the Big Dipper. The Big Dipper is an asterism, and it has a companion known as the Little Dipper. Now, the Little Dipper is known as Ursa Minor. The brightest star in Ursa Minor is Polaris. Right up top here, my cursor is at. There is Polaris. Ursa Minor means the lesser bear, the little bear. Now, right below the cup of the dipper, if you go down, continuing the arc of the dipper, you can find this. That is the Big Dipper. Now, if we find the Big Dipper, you'll see that the Big Dipper is part of another constellation called Ursa Major. So you have Ursa Major, the Great Bear, and you have Ursa Minor, the Lesser Bear, or the Little Bear. So the Big Dipper is known as an asterism. It is an unofficial constellation. It is part of a major constellation. We have other asterisms, such as the Summer Triangle, which is part of 3 other constellations. But we are going to use the Little Dipper and the Big Dipper to do some star hopping, to find some other bright stars, and then we're going to visit those stars up close. So to do that, we are going to use the 2 stars on the outer edge of the cup of the Big Dipper to point our way down to a very bright star known as Regulus. Regulus is the brightest star in Leo the Lion, which we just saw. So Leo the Lion is, you can use Leo and the Little Dipper, and in between those 2 you can find the Big Dipper. Now the Big Dipper, the Little Dipper, and Leo are 3 constellations that are very easy to find, even though the Big Dipper is an asterism. Ursa Major is very easy to find. Ursa Minor, Leo, all easy to find. But there are 2 other constellations that are a little bit more difficult. To find them, we're going to go back to the Big Dipper. We're going to find the handle of the Big Dipper right there. And see how that has an arc to it? Well, we're going to use that arc, and we're going to continue the arc. We're going to arc our way down to this very bright star known as Arcturus. Now, Arcturus is the brightest star in the constellation Boötes the Herdsman. It's a very odd name, Boötes. Now, there's some conversation about what the name actually means. It could be Latin for noisy, but it's also known as Boötes the Bear Chaser, because as the sky appears to spin, as the sun and stars appear to rise and set, it appears that Boötes is sort of chasing the Little Dipper and the Big Dipper, or the large and small bear, around the pole star Polaris. So that's Arcturus. So we arced our way down to Arcturus. Now we are going to speed our way, or drive a spike downwards to Spica. And Spica is the brightest star in the constellation Virgo the Maiden. So there you have some very prominent constellations that you can find in our nighttime sky. And it's the second time this little message popped up on my screen. Disregard. There is the artwork for those constellations. So we can find other constellations in our nighttime sky. We're not going to really go over all of those. There are 88 officially recognized constellations that you can find. Just about every bright star you see here has a constellation that corresponds with it. Corona Borealis, I can show you that a little bit later. Let's see here, Corvus the Crow. We have Hydra the water snake down there. So So yeah, just a lot of different constellations that you can find just all over the place. 88 officially recognized constellations. Now, we're not going to go over all of these constellations. We're just going to go over the ones that we just talked about. But let's do a little experiment here. Let's see here. So these are all very easy to find. So here's another shot from my backyard. So what's the first thing that we're going to do? We are going to find the Big Dipper. So again, look around for the arc of the handle and the 4 stars that make up the cup of the Big Dipper. Let's take a second to kind of look around here. Might need to get closer to the screen. If you have found those 4 stars, that is the Big Dipper. So what are we going to do? We're going to arc our way down or continue the arc, since it's our orientation is a little bit different. Continue the arc to the next brightest star you see right there, Arcturus. Continue that down to that very bright star, which is Spica. And there is some lines I have drawn there. So there's the Big Dipper. Continue the arc to Boötes and the bright star Arcturus, and then continue on to Spica. Well, we have gone over some interesting stars. Let's go and actually visit those stars up close. So the first star that we talked about was going to be Polaris. And this is going to be an interesting star to look at. We're going to center ourselves on Polaris. You should be right in the center of the screen. So look right in the center of the screen to find Polaris, that brightest star there. There it is, and there is its constellation in Ursa Minor, and now we are going to go to Polaris to see what it actually looks like. Now, as we go to Polaris, it is around 433 light years away from us. It is the brightest star in Ursa Minor, and as we get closer to it, we will begin to see that Polaris is not a single star, but it is actually a triple star. So you have 1 star right there, you have 1 star right there, and if we get even closer to it, you will see Polaris. There we go. Getting a little bit closer. There we are. There's the other star. Now, if I dial down the exposure, we can see the other star right there. So let's increase time a little bit to see how these stars orbit each other. Woo, a little too fast. And we'll bring up the exposure like it should be. So now we can see those stars and how they orbit. So Polaris is a triple star system. If we look at them compared to each other, we can see that they vary in size as well. Polaris A, B, and the main Polaris AA, AB, and Polaris B. Now, most stars that we find in our nighttime sky are going to be double stars and triple stars. Now, Polaris is known as the pole star. It's known to have that. Let me pull this up real quick here. Back to Stellarium. Bring these down. Those names. Because Polaris resides right on... Oops. So there is due north right there. Polaris is known as the pole star. It is Latin for pole star. It is located almost directly at due north. So as the sky appears to spin, Polaris will remain stationary. That is why navigators, navigation, people who used to sail would follow the North Star. They could trust that the North Star was due north. Take that down. Okay, where were we? We were at, there we go, there's Polaris. So it is also not the brightest star you can find in the sky. I know that Polaris, or the North Star, is one of the most famous stars, but it's actually about the 47th, about the 48th brightest star. So we also talked about, let's go ahead and go home. We also talked about Arcturus. We arced our way down to Arcturus. So let's take a look at Arcturus and how different Arcturus is to Polaris. Oops, there it is. And if you remember, Arcturus can be found, there it is, in the constellation Boötes. So let's head out to Arcturus. Not as far away as Polaris. This is only about 36.7 light years away. It is the fourth brightest star overall in the nighttime sky. So as we get closer to Arcturus, we will see that it already looks a lot different than Polaris. It's by itself. I'm going to increase time a little bit here so we can see this cool solar weather kind of coming off of it. Nice. 36.7 light years away from us. It is known as a red giant star. Now this means it has consumed the hydrogen around the core and in the core, and now it is consuming the helium. When it does this, it becomes huge. Dial it down here. Take a look at the surface. It's fun to mess with the exposure of these so we can see the actual surface of the star. So here's Arcturus. So it has consumed the hydrogen in its core. It's now consuming helium and is now much larger than our own star, the Sun. Let's see here. Pull away a little bit here. Bring this back up. Right. So what else did we cover? We arced our way to Arcturus, and then we speed our way to Spica. Let's go back home to see where Spica is at. Oops. Spica. Get rid of that. And Spica is the brightest star, of course, in Virgo the Maiden. Now when I bring this up, you'll see that Virgo looks a little bit different than the constellation pattern we saw before. Constellation patterns kind of vary from place to place, but the stars that make up those patterns remain. So there we are at Virgo, and now let's make a trip out to Spica to see what Spica looks like. So we had a triple star system. We had Arcturus, which was a single star, and now as we get to Spica, we see that Spica looks also a lot different than Arcturus. Arcturus was a red giant star, while Spica is actually a binary star system. It is two stars. Boom. Two stars orbiting each other around a common center of gravity. Speeding up time there. There we go. Looks nice and pretty, huh? So you can see that now Spica is two stars, a double star system. They both orbit a common center of gravity every 4 days. Now, both stars are much hotter than our sun. You can see that these are blue stars. Arcturus was a reddish star. Well, the blue and the blue-white stars are the hottest stars of all. Now, you might think that's a little bit contrary to what we usually think of. We think of blue as cold and red as hot, but when it comes to stars, it's a little bit different. Next time you take a look at a candle flame, take a look at the wick of the candle flame. The very tip of the wick is going to have a bluish tint to it, and then it's going to go kind of orangish, and then the very edge of the flame should be red. So that is why the color of the stars is a little bit different as opposed to the way we look at faucets. Blue being cold and red being hot. It's opposite. Blue and blue-white stars are the hottest stars of all. Now these two stars are separated by about 11 million miles. Now, in contrast, the distance between our Earth and the Sun is about 93 million miles. So these two stars are actually pretty close as far as astronomical terms. So let me just kind of dial down that. Kind of take a look here. And there we go. Pull in a little closer there to see how these stars look. It's nice and pretty. Well, the word Spica actually means ear. It is Latin for ear. And the reason is Virgo the Maiden is depicted as a beautiful maiden who has an ear of wheat or an ear of corn. And so Spica represents that ear of wheat in her hand. So now we're about 36.7 light years away. I'm sorry. Arcturus was 36.7 light years away. Spica is actually 10 light years away. I'm glad I just caught that. Okay. Well, what is a light year? So the distance between the Earth and the Sun is what is known as 1 astronomical unit. It takes light from the Sun 8 minutes to reach Earth. So if the Sun were to just sort of blink out of existence, we wouldn't know until 8 minutes later, until that last bit of light reached us. So 1 astronomical unit is 8 light minutes. Now, light is the fastest stuff in the universe. It travels at about 186,000 miles per second. So a light year is how far light can travel in 1 year. So what you do is you multiply the number of seconds in 1 year by the number of miles that light travels in 1 second, and you've got something like 5.88 trillion miles. I just realized I have not gone to Regulus. Let's go back home and take a look at Regulus. I didn't do this in the first show either. Kind of skipped over Regulus. For fun, let's look at Regulus. I spelled it wrong. And to make sure we know what we're talking about, there's Regulus. There's Leo. Again, it looks very different than what we're used to seeing. Leo. I don't like these depictions of okay, here we are at Regulus, getting close. Okay, and as a comparison, we will take a look at what we are seeing in Regulus. So Regulus has 4 stars. Regulus A, Leonis B, Leonis C, Leonis D. Let's take a look at that. Let's speed up time quite a bit to see how these stars interact with each other. Oops. See this over here, which of course is Leonis C and D. We have these fellows over here. Down, exposure to tad. Okay. This is difficult. Okay. Hang on. Center on that again. There we go. Okay, that's nice. Okay. Bring that up. Okay, so we've gone over Regulus, Polaris, we've gone over Spica, and Arcturus. So what else can we find in our nighttime sky? Let's get out of this. Save myself some computing power. Ah, yes, over here. Great. We have Jupiter and Saturn. And as time increases here, we will see Jupiter and Saturn coming up over the southeastern horizon. In fact, here's a picture again from my backyard with Jupiter and Saturn coming up over the horizon late at night. With all the fog, even with all this fog and light pollution around, you can still see Jupiter and Saturn. So let's go visit Jupiter and Saturn up close. I don't need that one anymore. Here we are. Good. Get rid of these and those. And we're going to go visit Jupiter first. Oh my gosh, where am I at? Here we are. Okay. I'm going to keep these orbit lines up so we can kind of get a sense of where we are going. And here we are approaching Jupiter. We can see those moons of Jupiter, the Galilean moons of Jupiter. As we get closer to Jupiter, where's that red spot at? Over here? I found that red spot. There it is. Okay, in order to see the red spot, let's see here. Wrong way, wrong way. There we go. Okay. There we go. I'm going to take a look at the great red spot of Jupiter. Well, on the way to Jupiter, we came across those moons of Jupiter. Well, Jupiter has 79 confirmed moons. It's a great red spot that we all know of changes in size over time. At one point, it was large enough that you could fit 3 planet Earths side by side in this red spot. Now it's about the size of 2 Earths. So, question is, and I've answered this before, but I do like to answer this question, is what would happen if you were in a spaceship going across Jupiter and you decided to jump out and visit it up close? Well, Jupiter, along with Saturn, Uranus, and Neptune, are known as gas giants. There's nowhere to land on these planets. It's just gas. And we think, not we, but scientists think and astronomers think that at the core of these planets is liquid metal, super condensed liquid metal. So the bulk of these planets is going to be gas, ammonia, hydrogen, helium gas. So if you were to jump out of a spaceship and go directly into Jupiter, the first thing that would happen to you is when you got around 200,000 miles from the surface of Jupiter, the radiation from the planet would penetrate your suit and kill you almost immediately. So, in order to continue this thought process here, we need to get a different type of spacesuit, some science fiction-y spacesuit that some genius came up with that would be able to withstand the radiation of Jupiter. So let's say you had that type of spacesuit and you jumped down into Jupiter. What would then happen? So once you hit the surface of Jupiter, the cloud layers of Jupiter, you would then start falling at about 110,000 miles per hour, since the gravity on Jupiter is so much greater than it is on Earth. And you would keep falling for about 12 hours. Now, if your spacesuit was still made of some type of submarine material and you were to survive this, you would then see that you were surrounded by this colorful tornado, because these cloud bands, these colorful cloud bands, those are all storms raging across the surface. So it would appear that you were inside a huge tornado. And then you would keep falling until eventually you would hit that center. Now, whether that center is solid or liquid or whatever it is, you would be pasted to that core, unable to move, unable to get up, because the pressure and the atmosphere on Jupiter is millions of times greater than it is on Earth. So, jumping into Jupiter, ill-advised. And what is next? What we have is Saturn. Saturn's next. Let's visit that. Can we keep those lines up there? We see Saturn has also a large number of moons, not as many as Jupiter, 62 confirmed moons. But as we get closer, many of those moons reside in this ring system known as shepherd moons. That kind of keeps the rings in order. Now, the ring system of Saturn is so vast, it's almost the distance between the Earth and the Moon. Earth over here, Moon over there. Almost the distance between the Earth and Moon. And again, you can find Jupiter and Saturn for yourself as they come over this southeastern horizon. And that, folks, is going to wrap up our spring nighttime sky. Do hope you enjoyed a recap of what we were able to find in our nighttime sky in spring. Take some time for yourself to go out some clear, cloudless, dark night, to gaze up at the nighttime sky, find some constellations, get some binoculars, find where the planets are at. Take some time to kind of look up and kind of contemplate where we are at on Earth and our place in the rest of the universe. With that, enjoy the rest of your evening. I will see you next week with a summer version of the show. Good night.